Good day, everyone. Good day, sir. We are the group 3 and we are assigned to discuss the example calculation of sextant altitude by stars and planet. So, for our group members, we have Cadet Caballero Kyle, Cadet Kapangpangan Philip, Cadet Cavite Francis, Cadet Iharis Russell Kane, and Cadet Hava John Simon. So, for our learning outcome, let's welcome Cadet Cavite Francis.
After the report, students are understand the calculation of sextant altitude by stars and planet. So, first, what is a sextant? So, a sextant is an instrument for determining the angle between the horizon and celestial bodies such as the sun and the moon or a star, used in celestial navigation to determine latitude and longitude. The device consisted of an arc of a circle, marked off in degrees, and a movable radial arm pivoted at the center of the circle.
Good day, sir. I'm Cadet Iharis Russell Kane, and I'm here to discuss of what is celestial navigation. So first, celestial navigation uses sights or time angular measurements taken typically between a celestial body. For example, the sun, the moon, a planet or star, and the visible horizon. So, celestial navigation can also take advantage of measurements between celestial bodies without references to the Earth horizon, such as when the moon and the other selected bodies are utilized in the practice called lunars, or lunar distance method, used for determining precise time when time is unknown. So, sextant altitude by stars. Sextant altitude by star. Find the altitude of star Rigel on 16 September 2001 when the sextant altitude was 36 degrees and 28 minutes. The height of eye was 10.8 meters and index error was nil. So the solution is sextant altitude is 36 degrees and 28 minutes. So the index error are still missing. So we will find the observed altitude by between in 35 degrees and 38 minutes of 37 degrees and 45 minutes. So the deep and whole 10.8 is 5.8. So we will subtract by the 36 degrees and 28 minutes of 5.8 minutes, and the apparent altitude is equal to 36 degrees and 22.2 minutes. So the total corrections is 1.3 minutes. So is equal to the true altitude is 36 degrees and 20.9 minutes. So that's all, sir.
So, sextant altitude by star. Find the altitude of star Rigel on 16 September 2001 when the sextant altitude was 36 degrees 28 minutes, height of the eye was 10.8 meters, and the index error was nil. So the solution was the sextant altitude was 36 degrees and 28 minutes, and there's no index error. The observed altitude was the same as the sextant altitude, 36 degrees 28 minutes, and the IP and HOE was negative 5.8 minutes. So we need to subtract the two. 36 degrees 28 minutes minus 5.8 minutes is equals to 36 degrees 22.2 minutes. And the total correction was negative 1.3 minutes. and we need to subtract the apparent altitude and the total correction. So the answer is 36 degrees 20.9 minutes. So sextant altitude by planets. Find the true altitude of planet Venus on 18 June 2004 when the sextant altitude was 46 degrees 17 minutes and the height of an eye was 7.9 meters and the index error was nil. So the solution was sextant altitude is 46 degrees 17 minutes. The observed altitude was 46 degrees 17 minutes and DIP and HOA was negative 4.9 minutes. And we need to subtract the observed altitude and DIP HOA. So the answer is apparent latitude 46 degrees 12.1 minutes and the total correction was negative 0.9 minutes, and to subtract the two, the answer is 46 degrees 11.2 minutes and the additional correction is positive 0.2. So we need to add the two, and the true altitude was 46 degrees 11.4 minutes.
So in this slide, we have the sextant altitude by planets. So find the true altitude of planet Venus on August 2004, when the sextant altitude was 45 degrees and 17 minutes. So for the height of the eye, we have the 7.5 meters, and the index error was nil, or we don't have any index error. So we have the solution, which is the sextant altitude, which is the 45 and 17 minutes, and we don't have any index error. That's why our observed altitude was 45 degrees or 17 minutes, or they are the same. So now we need to find the 7.5 meters on the almanac. So on the left side we have the meters, and the right side of the picture we have the feet. So we have the 7.5 feet. So now we have the 4.9 minutes. So we need to subtract the 45 degrees and 17 minutes to 4.9 minutes. So we have the apparent altitude, which is 45 degrees 12.1 minutes. Now we have the total correction. So for that, we need to find the 45 degrees and 12 minutes. So on the left side of the almanac on the picture, as you can see, so we have the 1.0 minutes. So when we subtract, we get the upper altitude, which is the 45 at 11.1 minutes. So for the additional correction, we have on the given, we have the 1st of August 2004. So as you can see in the middle row, we have the positive 0.2 minutes. So that's our additional correction. So we need to add apparent altitude and additional correction. So we have the true altitude, which is the 45 and 11.3 minutes. So for the next slide, as you can see, we have those links. If you have any clarification or questions, or you didn't understand something, so you can use those links that we provide. That's to fully understand what I've discussed for. So thank you for watching, guys. Hope you learned something in our discussion.